Okay, let's get started. So I've been trying to figure out a way to convey the map information to you and to the people who are taking it online in some sort of effective manner, and I've just done a really terrible job at it. So I'm going to try this. Hopefully this will work a little better. It's always easier when you actually have a map in front of you rather than try to watch a video about it. So first things first, how many of you have used topographic maps before? None of you? Maybe just a little bit? So, okay, I'm assuming you guys know nothing about topographic maps, and that's all right. So these topographic maps are going to be kind of the base for a lot of work that we do in the environmental sciences. It's a map that gives us information about what's going on the land surface at these various areas. It tells us about the topography, it tells us about water, it tells us about human-made structures, gives you an idea of what's there. In a couple of weeks, we're going to look at a different kind of map called a geologic map. And a geologic map is nothing more than a topographic map, which you have in front of you, with the rocks that are on the Earth's surface at each of those locations on your map. And that provides us a lot of information. It tells us what's going on the surface, and there's some little symbols on those maps that are going to tell us what's going on beneath the surface as well. So we kind of get a three-dimensional view of what the Earth looks like, not only on the surface, but beneath it. So we can use that to think about things like groundwater, which exists in the Earth. We can think about what sort of structures are stable in those areas, things like that. We'll also look at a soils map, which shows you what sits on top of the rocks in those areas. So you have soils, and then you have rocks, and then you have the topography. So let's kind of walk around these maps here, and I'll try to introduce you to them and all the different information that they contain. So the first thing is that maps have a name. Each map is usually named for some prominent landmark that exists in the map area. So in the upper right corner, you have a map name. If you're watching the video, it's the Greeley Quadrangle. So that big sort of pink area in the lower center of the map, that's the city of Greeley. So this map is named for the most prominent landmark in the area, and that's the city of Greeley. For you guys sitting out in class today, I think I put the Masonville map. And Masonville is a little town right near the top center of your map. It's a little town just a little west of Fort Collins. So that shows the area. There's the Longs Peak map. Maps all over the United States having slightly different names. The type of map that's on the screen and in front of you is called a 7.5 minute map. Now, the Earth is 360-degree sphere, right? Every degree has 60 minutes, okay? And this particular map shows 7.5 of those minutes, both north to south and east to west. It's probably the most common type of topographic map that's out there. So in this case, just to give you an idea, the map that you have sitting in front of you is probably 7 miles across in real life and maybe 8 miles up and down, north to south in real life. So, you know, it's a sizable area, but not huge, and you can start to see some of the details. The second most common map is a 15-minute quadrangle. And those are just designed to show a slightly bigger area. So 15 minutes would be twice as wide as this map, and also twice as deep as this map. So a 15-minute map would actually be 4 times the size. Okay, so twice as wide and twice as deep, 4 times the size. Let's see, what else is on there? So we're going to look at kind of the edges of the map and the middle of the map here in a minute. But near the top, it gives you the information on what the map's name is. On the bottom, we'll get to that in a second, there's lots of information on scale and magnetic north and true north and things like that. So let's sort of move forward here. Okay, So as I said before, each map has a name. In this particular map that I have on the screen, we have the Greeley quadrangle right there. Probably the most prominent marking on your map are all the brown squiggly lines. You guys see that, right? Those are called topographic lines, and they connect points of equal elevation, okay? So you can see that some lines are darker than others too, right? Take a look at your map and you'll see that basically every fifth line is a little darker. And it's typically those darker lines that actually contain the elevation on them. You'll see a number. So let's see what we have here. So right here on my Greeley map, is a darker contour that says 4720, okay? So that's the elevation, 4,720 feet. Here is another one, just a little north of this 4720, and that is 4750, okay? And you can see here's 4740, 4730. The elevation is going up 10 feet every line, okay? So those lines connect points of equal elevation. The difference between those elevations of adjacent lines is something called the contour interval. In this case, the contour interval is 10 feet. So every time you have a topographic line next to another one, it either goes up or down by 10 feet. Now, that changes depending on where you are. Now, if you're in a really flat area, think of an area east of Greeley or somewhere else that's perfectly flat. You don't want a contour interval of 100 feet on your map because the whole area may only vary in topography by 10 or 15 feet. And a map with one line on it is pretty boring and it doesn't tell you much. So you try to find a contour interval that will show you the details of the surface of the land without giving you too much information or too little. So you don't want just two lines on your map. At the same part, if you had a map, say, of Long's Peak, where it goes up 7,000 feet really abruptly, you don't want a contour interval of 5 feet, let's say. Or you'd have literally hundreds of lines all over your paper and it'd be hard to read. So in a case like that, you might have a contour interval of 100 feet or 200 feet. So the contour interval sort of matches the relief or the maximum change in elevation as you move across your map. Okay, you notice your map is rectangular, right? And it only shows a small area. Like I said, maybe 6 miles across, maybe 8 miles north to south. Let's say you were in this area over on the right side or the east side of your map. Let's say you're there. And you want to know what's over here. You know, I need this map. I'm going to go east. I need the map that's over here, right? Well, this topographic map actually tells you the maps that are adjacent to this map. So if you go in the upper right corner, there is a map that's going to fit right in this upper right corner right here. And that map has a name. It's listed in black. And this particular one would be the Eaton map. Okay, there's a map that sits right to the north of this map. Right up in this area here. That map is also called the Eaton map. There's a map over here. On mine it's called Eaton. On the Masonville it'll be different. And then you can see along the left margin and right margin there are names for maps that fit there. So you'll see all the adjacent topographic maps that you have. The other thing that you will notice is that there are a lot of roads on your map, okay? And those roads will go off the map. And a lot of times they will tell you where prominent cities or things are. So this place right here, it says that the town of Barnesville is 8.3 miles directly to the east on my map. If you're looking at the maps out there, you can see, I think on the bottom right of your Masonville map, You can see Highway 34. It goes off the east edge of your map down around the big lake that's down there, Lake Bedecker. Do you guys all see that? And it tells you how far I think it is to Loveland. So that's not the map you would need. It's not the Loveland map. That just tells you where the town is. The map that actually fits over there, well, it's actually called Loveland. If you see, like, right in the middle of your map, the name of the map is in black and in parentheses, right? You guys can see that? Good. Okay, what else do we have here? So we have contour lines. You also note that there are blue areas, right? Water. Okay, so you have areas that are lakes. On your Masonville map, if you look at the lower left or the southeast part of your map, you see Lake Bedecker down there. Right here on my Greeley map, I have Seeley Lake. And then you see lots of little rivers too, solid blue lines. Okay, so I've got some like right here near the town of Lucerne. Now, if the line is solid blue, that means that that river is flowing year-round. Okay, that means it'll always have water in it. The amount of water is obviously going to vary. Be high in the spring when you get snowmelt or after rainstorms. And it'll be low in the summer after you've had prolonged periods without any precipitation. You will also see on some maps, I don't think I have any on here, but on your Masonville map, kind of in the northeast part of your map, remember, up is north, down is south, to the right is the east, and to the left is west. So if you look in the, let's see, northeast part of your Masonville map, you'll see a river up there. I can't remember what it's called. Let me look here really quick. Let's see. Yes, Indian Creek. Exactly. So if you look at the northern part of it, you see that it's dotted, right? Dotted and dashed. That means that part of the year that river might go dry. So it means that groundwater probably isn't feeding that, or very little groundwater is feeding that, and it relies heavily on runoff from rainstorms. But as you go farther south along Indian Creek, you'll notice that at some point it becomes a solid line, right? So that area is going to have water in it all year long. The other kind of interesting thing is you might want to know which direction the rivers flow. Okay? How would you figure out which direction the river flows on your map?
By elevation?
Yeah, you could look at the topographic lines as they cross the river, right? And find an area that's higher than a different line, and then it's going to, water always flows downhill, right? So you can see the direction. But remember, not all topographic lines have numbers on them. So sometimes it is difficult to easily figure out which direction a river is flowing. There is a little trick, and it's to simply look at the shape of the topographic lines as they cross a river. And what I'm going to do is I'm going to look at, let me get rid of that line right there, let me get rid of some of this stuff. On the map that I have on the screen here, pay attention to that area right there. So we have a stream that's either flowing into Seeley Lake or out of Seeley Lake. Now, you could look at the numbers, and this says 4750 right here. And then this is 4720 down there. So this is higher than this, so it's going to flow from the north to the south, right? What if you didn't have numbers on it, though? And if you look at your map, you'll see a lot of those lines don't have numbers on it. You notice the little shape of the contour line as it crosses the river. So look at this contour line right here. Makes a little V shape, doesn't it? And that makes a little V shape. And that makes a little V shape. One thing you should know about streams is that when the contour lines cross them, the V's always point uphill. Always. And I can show you here in class. I can't show the people at home why. But, all right, pretend that this map that I'm holding is a river valley. Okay? If I put water in it, which direction is it going to flow? It's going to flow towards you, right? Now remember, too, that Let me flip this over. I'll do it this way. Topographic lines connect points of equal elevation, right? So let's say we have a topographic line that's the same elevation as the tabletop. Okay, this tabletop right here. If I drew that on the map, what would it look like? It would make kind of a U-shaped, right, or a V-shape. And that points towards me, right? The river flows towards you. So that little V is actually the little river valley that surrounds it and what the topographic line does when it crosses that. But just to keep things simple, remember that topographic lines point, they V uphill, okay? Well, let's see, let's move forward a little bit. We'll look at the bottom part of your map here. Okay, down along the bottom, there's lots of information on your map, okay? One thing I want to point you to right here is there should be a couple of arrows at the bottom. One may say true north or geodetic north or GD, and it generally points straight up on your map, right? And then if you look, there's another arrow right here that'll point off to the side a little bit. That's magnetic north. Okay? Remember, magnetic north and true north are not the same place. And as we talked about a couple of class periods ago, magnetic north is moving around, right? It used to be a much more stable feature than it is today. But here, if you look, it says that magnetic north is actually 14 degrees off to the east than true north. And that was in 1950. It's not the same today. In fact, there's places where you can go online and see just what it's called declination. It's the difference between true north and magnetic north. You can see what that is today. The point being is that, let's say that you were right here. Let me just put this little X right there on your map. And you took out your compass and you started following your compass north. What path would you follow? Would you go straight up the map? No, you're going to follow magnetic north, so you're actually going to move off to an angle. Because magnetic north and true north are separated on my map by about 14 degrees. So if you're near, let's say, let me get rid of all this. Let's say you are right here, okay? And you're hiking along and you're following your compass rather than some other navigational device, and you hike for several miles true north. What map are you ultimately going to end up on? You're going to be the one that's off to the east, right? In my case, I don't know what that is because I don't have that information sitting in front of me. Who knows, it's probably Eaton. If you're off on your map, I think you end up on the Loveland map, right? Yep. So it's important for being able to navigate across the map. The other thing that this has are some scale bars down here on the bottom. Okay, it tells you distances. You got to be careful with these bar scales because the 0 is usually in the middle. I don't know why they do that, but they do. So in this case, this distance here is 1 mile. The whole bar is 2 miles across. There's another scale there as well that's really useful for geologists. It's right here. It says scale 1:24,000. Do you guys see that on the bottom of your maps out there too? That means that this map is exactly 1/24,000th the size of this area in real life. Or in other words, if you blew this map up 24,000 times, you'd be able to perfectly lay it over that area. Another way is that you can do some math with this too. So what that says is that every unit on your map, so let's say something measures an inch across on your map. In real life, it's 24,000 inches. Okay? So 24,000 inches, there's 12 inches in a foot. 24,000 divided by 12 is 2,000, so 1 inch would be 2,000 feet on your map, or so on. So any unit, this unit, that unit, an inch, a centimeter, is 24,000 of the same units in real life. So if you measure something on your map and it's a centimeter across, in real life it's going to be 24,000 centimeters. Make sense? Excellent. Okay. Now finally, to me, one of the most useful things on the map, notice that there are a bunch of red squares all over your map. You guys notice that? There's lots of red lines moving up and down. What's at the center of every red square? There's a number, right? And you will see numbers between 1 and 36 all over your map. Never less than 1, never more than 36. Those are called sections. And a section is 1 square mile. So each side of that square is a mile. It's a really handy way to measure things, okay? So those are sections. So not only is it a handy way of measuring things, we also, the main reason that we have section numbers on here are to locate things, so that you can tell others where things might be. Or if you own property, it can tell you exactly where your property is. Okay, so let me give you an example. Let's say my property is, that's a bad drawing. Let me try that again, okay? Let's say I have property that is right there. Okay, I'm a professor, I don't have a huge amount of land. Actually, that's a fair amount of land. One thing, these sections are 640 acres each, okay? That's kind of useful to know. So each section is 640 acres. If you deal a lot with environmental science or earth science, that's just one of those things that you end up knowing, okay? 640 acres per section or per square mile. So that little square I drew there, I don't know, that's several acres. It's actually a fair-sized piece of land. If you're going to tell somebody where it is, what would you tell somebody? You could try to do longitude and latitude, right? But you end up with all these fractions of a degree and things like that, and it's not terribly useful. This can be a little easier. I could say it's in section 24, right? And that narrows it down a fair bit. Doesn't narrow it down enough though, does it? Square mile's pretty big. One thing I could do though is I could divide that section into quarter sections. Okay? So if I did that, we could say that this is the northwest quarter, this is the northeast quarter, this is the southeast quarter, and this is the southwest quarter. Now what would you say? Yeah, you could say it's in the northwest quarter of section 24. Okay, in real life though, I have like a half acre that I own over by Fort Collins. A half acre on this is super tiny, isn't it? You know, so remember, if this is 640 acres, right? Each quarter is 160 acres. And I own a half acre. Okay, so my land would be really tiny in here. And if you ever buy land, what you'll see is you get a deed, right? And your deed tells you where your land is. And it actually uses this system. So we need to narrow this down a little more. All right, so what we do then is we take that northwest quarter of section 24 and we divide that into quarters. Now where is it? It's now in the southeast quarter of the northwest quarter of section 24. And when you write it, what you do is you start with the smallest quarter section first. So we would write this southeast quarter of the northwest quarter of section 24. And then actually I could subdivide it again and again and again and again, depending on what the size of my property is. I looked at my deed and it said like northwest quarter of the southeast quarter of the southwest quarter of the southeast quarter of the northwest quarter of the southeast quarter of section 18. And that's what your deed will say. And it'll do that for each corner of your lot. So you'll know exactly where it is. In this class, we're going to go to the nearest quarter of a quarter section, like I just did. So I'm going to ask you on your labs, where is the easternmost shore of Seeley Lake or Lake Baedeker? And you will always give those to me to the nearest quarter of a quarter section. Now, as it turns out, remember sections run from 1 to 36. They're never more and they're never less. So how many section, in this case, this is section 24, right? How many section 24s do you think we have in the United States? Lots of them, right? So we need another designation in order to say which section 24 are we talking about. Because even on your map, you're going to see the same number repeated several times. You probably have a couple of section 8s or a couple of section 6s or a couple of section 26s. Okay? So I need to introduce another measurement concept to you, and that is something called a township. You guys may have heard of this term before, maybe not. A township equals 36 square miles. How many sections would that be? 36, because each section is a square mile. So that means 36 sections. And the way townships are numbered is kind of unique, and I don't have great art skills, so I may really botch this, okay? I apologize ahead of time. I'm going to try to do this. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. I did that wrong. Get rid of that one. Okay. And then 1. Okay, those are supposed to be perfectly square, all right? And the way townships are numbered are like this. It's kind of the way you would plow a field, is how it was described to me. So 1 is in the upper right corner, and then it goes 2, 3, 4, 5, 6, 7, and that goes back across 8, 9, 10, 11, 12, down 13, and then it just sort of plows its way back and forth. Try that again. Glad I can erase this stuff. Okay, so that's how a township is numbered. So 36 square miles, or it's kind of a square 6 miles by 6 miles. So a fair size area. Take a look at your map, all right? How many sections do you think are on your map? You could count them quick. Your map is probably 6 or 7 sections across, right? And maybe 8 sections deep. So your map is generally about the size of a township. Okay? But the townships aren't perfectly aligned with the maps. And if you look, you might have 4 different townships partially on your map. Okay? How many townships do you think we have in the United States? I mean, think about that area right there. That's a really small part of just Colorado, right? And then think about the whole United States. We have thousands of townships. So how do we designate which township we're talking about? Well, this is something called the PLSS, the Public Land Survey System. It's been used by geologists and land surveyors and scientists forever, well over 100 years now. So let me show you what we're talking about here. I gotta get rid of all this stuff. Take me a minute to erase all that. All right. Okay, so what we do to designate different townships is we draw some imaginary baselines across the United States. So we just have a north-south baseline and an east-west baseline, okay? And what we do is we then stack rows of townships on top of this, okay? So we will have a row of townships that go right here, okay? So if this is our baseline, let me do that again. Let me make that a different color just so. So the red is the baseline. That blue represents our first line of townships, okay? So we're going to have lots of townships in there. We're going to have one there, one there, one there, one there. Some over here too. So each of these squares, which are really terrible squares, sorry about that, this is a township, 36 square miles. So if I tried to put the section numbers in there, the sections would be really small like this, okay? So every single township that's on this first row north of the baseline gets the designation T1N. Let me rewrite that. It's the first tier of townships north of the baseline, okay? I can put another row of townships right above that. And this one would be T2N, second tier of townships north of the baseline. Next row would be T3N, T4N, so on. What do you think the first row of townships south of the baseline is going to be called? T1S. Second row would be T2S and so on, okay? Now, if you look along the right and left boundaries of the map that you have in front of us, okay? In red, somewhere on that side, you are going to see numbers, okay? On your Masonville map, it is almost exactly halfway up, okay? You can see the dividing line between T5 and T6, right? And yeah, so that's the dividing line between townships that would be several rows up on what I've drawn here, right? So every single township on that first line is going to be T1N. But there's still a lot of them, right? So that's what that other baseline, the north-south baseline, is for. So what we have is another row going north to south that is east of the line. That gets the designation R1E. The next line over would be R2E. All right, if I go to the other side of the baseline, I want to take a stab at what that designation is going to be. R1W, R1 West. All right, so I will ask you this question. What is the designation for that township right there going to be? It'll be, what's the T number going to be? T2N. What's the R1, 2, 3, 4. R4 East, right? Is there any other township that's going to have that designation? No, there'll be no other one in the whole United States. So now, let's say we had, say we were right here, okay? So we can't see down to the sections because they're too small, right? But let's say we had a section 1 in there. Maybe the northwest quarter of section 1. What is the T number going to be for that right there? T2N, R, R2E. So W, sorry about that. R2W. Talking too fast here. R2W. Now you have a sort of a unique description that will only fit that area. So let me give you an example for those of you, even the people at home have the Masonville map. So look at the farthest western edge of Buckingham Lake, which is down right sitting on top of Lake Baedeker. Okay, everybody see that? So take a look at your map, find Buckingham Lake, find the farthest western point of Buckingham Lake, and give me the description of that location to the nearest quarter of a quarter section. First of all, what section is it in?
17.
It's in section 17, right? So then divide it. It's in the
Southeast, southeast, second quarter, southeast corner.
okay, western part will be in the
Southwest.
southwest quarter of section 17. Then go ahead and divide that quarter again.
Southwest.
So it'll be southwest of section 17. What's the T number? Okay, remember you have the T and R along the edges of your map. You'll find the dividing line between T6 and T5, right? And remember, those townships go for 6 square miles along one edge, okay? So it is in T5 north, right?
R69W.
And R69W. Everybody following that? If you're not following that, stick around after class and I can walk you through that. So that's how you locate things to the nearest quarter of a quarter section. All right, so the T is on, you find it on the left and right edge, right?
Yeah.
So you see the 5, right?
Yeah.
And remember, it goes for 6
Down.
miles.
Mm-hmm.
So that's all part of T5.
Oh, I see.
Yep. So it's all part of T5.
Okay.
And the same way with the R number. So the R number is kind of a little right of center of your map, and it goes for then 6 miles in each direction. So everything to the right or east of it gets the designation R69W.
Yeah. Okay.
Make sense? Okay. Anybody having any issues that I can... Might as well get it done now because it's going to be a lot harder when you do it on your own at home.
Does
Yeah.
the T go first or the R? Like,
You know, when you write it out, start with the smallest quarter section first. Then go to the next quarter section. Then the section. And then, you know, the T and R are kind of the same size, right? But usually when you see it written, the T number is first and then the R. I don't know why. I don't know where that convention came from. I'm not going to be a huge stickler on those last two, but obviously you have to have the first two, smallest to largest quarter section correct to get these done right. Okay, so I emailed you a lab and you've taken your maps, okay? So work on those. I'll give you 2 weeks from today to finish those up. So today's what, the 15th? So do the 29th, okay? It won't take you more than probably an hour, hour and a half. Do the lab, send me the answers, and what I'm going to do then is I'm going to send you the answer key back so that you can look at what you did wrong, and then go and you have your map sitting in front of you, and then you can say, oh yeah, that's why I did it, or I don't have any clue as to what I did wrong, and then you can ask me and I can help you with it, okay? So the whole goal is to get you to be able to read maps at some point here, okay? And really start to extract some good information from it. Do you guys have any questions? All right, let's take a couple-minute break. Let me pull up the actual class PowerPoint and we'll get moving on that.